Good morning. How many Alvin Toffler fans do we have? Anybody? Anybody know anything about Alvin Toffler? Absolutely. So I was reading a book called Power Shift back in 1990, and a good part of what he was saying was going to happen has already happened, but there's still a lot left to happen. And smart sensors obviously are going to be key to our future. Okay, so from this point forward, I'm going to ask you to use some inductive reasoning. We're going to talk to you about security sensors particularly, but all that translates back and forth. Smart sensors are smart sensors. You can gather anything, and it depends on, like Dave just said, whatever you're going to do with it. That's up to you. Build business cases, and anyway, so one of my favorite folks also is Einstein, and he says imagination is more important than knowledge, so I'm going to ask you to use some of that. I see there's a lot of smart people, and I can tell you're smart because your eyes are still open after all of that data that you've just had interjected into your cerebral area. Okay, so today we're going to introduce the Security Oracle very briefly just to show we're germane to the conversation. We're going to introduce some gunshot detection sensor system. We'll discuss it. We'll talk about some other smart security sensors, and then we'll prime you up for the discussion to follow. So these are some of the organizations that I've either been in security management, dealing with all different types of smart sensors and technology. That's kind of been my thing. Spent a lot of time in the space program working with it, the DoD, doing a lot of things. So, and then a lot of time in industry, both internal to the industry and also consulting to industry. Some of the other folks that we have with us, and you always have to have a CIO these days, right? Keep you on straight and narrow, make things happen. But our CTO is important to have a good CTO operation going on. Especially these days. Automated reasoning is a big deal now. Dr. Smith heads up our automated reasoning program along with automation. So he does both, and that's kind of unusual from what he tells me in the industry to have somebody that does both. One of the projects we worked on was Miami-Dade County. We were tying everything into everything into everything. Basically traffic control systems, building automation systems, security systems, any system at all in the county was all going to come together and converge and come back to a fusion center. And then we were going to do what Dave was talking about. We were going to do sensor fusion, distill it, and then be able to act on it and have the system kind of tell us, human being, you need to do press A, press B, press C, because there's just too much information for you to take in and make your own decisions there. So he's an underwater autonomous guy out of the anti-submarine warfare program. And then Lynn Farron is our FBI agent, and he's a retired sniper guy and done a lot of training. And so, the human has to, at some point the human beings have to do something. And Lynn helps to take all that sensor information, human-machine interface stuff, get that trained, get law enforcement responding to help companies and utilities when bad things are going to happen. So some case studies about sensors. I've done a lot in the world of water systems and wastewater systems as a part of the things I've done. And so just to give you an idea, in San Antonio there's a water plant where nobody's there in the night. But there's about 40 or 50 cameras throughout the plant, security cameras. Well, they got an alert that something was wrong with the SCADA system in the plant. They couldn't figure out what it was. Something was wrong in the cabinet. And so they looked with a video system, and they were able to see that there was a small, fine stream with video analytics. It would tell a small, fine stream of oil being pushed out of the high service pumps. And it was actually hitting the cabinet and going down inside and messing up the DCS. So with Progress Energy as a security manager there, I used to make sure that video feeds, I would add different video feeds for folks in the control room, maintenance folks, things like that, people to look miles away and look in the plants in critical areas, just to see what's going on, see if there's leaks, oil leaks, things like that in power plants. And then in the power industry in the UK, they've been using video analytics cameras for a long time. They're actually smarter than the fire sensors to be able to detect smoke. They can see smoke before a human eye can typically see smoke, and they do a better job than the heat sensors or smoke sensors. So now I have a video to talk about the gunshot detection system that we're going to introduce a little bit today and discuss.
It's strange to believe that these islands of concrete and steel behave like living things. But what the latest data reveals is that if you double the size of a city, any city, you get an across-the-board increase in all the good and all the bad. That's their curse. But new sensing technologies are coming online that may be able to diagnose the ills of urban growth while protecting and even nurturing the good.
Adam 2 to dispatch.
Richmond, California, a working-class town tucked away on the northeast end of San Francisco Bay, has long had a reputation for urban scourges like poverty and crime. But within the city of 100,000, one of the roughest areas was the Easter Hill housing project.
There was a time where the police officers were told not to enter Easter Hill alone. You had to go in with 2 cars in order to make sure you had sufficient coverage.
But Easter Hill's changed. It's now called Richmond Village, and it's got an incredible bit of engineering that's keeping the peace. It's a device that tells police when and where a gun is fired. Here, designers run a test.
Mikhail, you ready for the test?
Roger, test fire number 1.
Proceed with test fire number 1 when ready.
The device uses sensitive microphones that pick up the sound of gunfire. The difference in time it takes for sound to reach each microphone allows the device to triangulate the location of the shot. At which point, a camera swings into action and starts recording.
Okay, did you get a gunshot?
The location looks good.
Mikhail, that last shot was 229 degrees and 2 degrees of elevation. Everything looks really good on this end. Nice work.
Roger that.
In Richmond Village, 16 of the crime prevention systems stand watch over the neighborhood. They're linked to an on-site command center monitored by police officers. They conduct periodic tests to ensure the system is always in working order.
Charles 31, countdown please.
Charles 31 copies. 3, 2, 1.
Test confirmed. Copy, thank you.
The system clearly works, but does it work to fight crime?
Since 2006, when the system was installed, the police department has not had any responses to Richmond Village in regards to gunshot violence or illegal gunshots.
So is this a case of technology changing human behavior? The result in this neighborhood has been nothing short of a transformation. Since the sensors went up, crimes involving guns have plummeted. The neighborhood's changed and today looks more like a squeaky clean subdivision than the dilapidated warren of tenements it was just a few years ago.
The system actually works very well as a deterrent for the criminals in terms of their normal behavior. They know that if you shoot, we will zoom in and we will get a face.
Using technology to inoculate cities against the ill effects of growth is just one application of our advanced sensing capabilities.
Whoop. I think we got synergistic there and jumped too many slides together. Okay, so just think how many other things this technology can do. All the things that Dave was talking about, this technology can do, has the capability to do that. So, and the word waveform was mentioned. I think we need to talk about that a little in the discussion, hopefully. Frequency analysis. And then we always want to get improved detection accuracy and eliminate false positives, correct? Because we don't want to make decisions based on bad data, and we want real-time data, right? So that's important, so it's a good thing that that's going on. And then with regard to event detection, looking for anomalies. So basically just looking for the information you need, information management approach to security or anything, just the information you need, nothing more, nothing less, right? So we'll ask one of the experts here, Sally, to talk about that a little bit during the discussion. So this gunshot detection system can hear anything from a .22 caliber, which is pretty impressive. That's not a lot of noise, to an RPG and a mortar. Hopefully, none of you have to experience being around those. And so, speed, accuracy, ability, all that's important with any sensor to be able to then actionable intelligence to be able to drive things like that camera that went right on target. That's what you want with any kind of a sensor. If you're doing process control or anything, you want to be right on target with regard to what you do, right? When you put the business case, the business rules in, you know, it does the right things, and you also want it to be able to to connect IP, and so connectivity is very important. In this particular case, this sensor is pretty advanced. It will detect supersonic distance less than 150 feet, 600-foot radius, urban settings, 800 meters in open areas, 360 degrees. One thing that's nice about this kind of sensor is unlike a camera and a lot of other sensors, you're going to get, you can hear, so to speak, in 360 degrees. Certainly they're coming out with cameras now that you can see in 360 degrees, but it's kind of a bit of information for a human to be able to handle. So it's good for a sensor to be able to pick it up and tell you exactly where the problem is. And also this sensor suite has the capability to do fence-based sensor and give you point ID with regard to that. And you just saw it deployed in an urban environment. So good news is it gives you elevation, azimuth, and then important enough is to bring it back and bring it into a geospatial environment so that a human-machine interface, so that your control room, control center, whatever it is, can understand where the problem is, know it, real-time situational awareness, and be able to act. Perhaps it'll give you an opportunity to decide what to do, whether or not to press yes or no for a process to be stopped or implemented. You may not want this sensor to actually stop a process. You may need a human still to make some decisions, but at least that can be presented to you on a silver platter, and then you can click, implement or non-implement. You can make that choice. So again, we want real-time intelligence, actionable intelligence situation that gives us good situational awareness, the best possible. Sorry about that. So with regard to it could be a safety accident. It could be anything that your sensors are picking up. You want to reduce the number of victims, control the expansion of the event. The sooner you know about it, you can try to keep the genie from getting out of that bottle, right? And so and in this case, no matter whether it's an on-site situation where you've got a lot of the workforce and folks reporting what's going on, or it's just out in the community where you've got witnesses making phone calls, usually like we saw in Lake Ferguson, Missouri, there was all kinds of different reports with regard to what actually happened. As we know, human beings see it with their perceptions and filters, and it's not actually always going to be good. And then this way you take the sensors and maybe a collection of sensors, and you get much better information. You can distill it, fuse it, and then immediately know what's going on. So you get this immediate intelligence regarding, in this case, gunshot events, where they've occurred exactly, when they've occurred and where they've occurred. And you can actually plot stuff, time lapse on your geospatial mapping system. So again, magnitude of the situation, number of shooters, direction fired is very important, and I'll talk about that in just a minute. Why direction of fire tends to be very important. Certainly, there's a need for this kind of sensor. There is plenty of gun situations going on here in the United States. Then there's these active shooter situations, and so maybe not just in process controls in your industrial environment, but also in your office areas and things. These days we have to worry about active shooters occurring in those corporate environments, and so there are great opportunities now to sense throughout a building, structure, an area, a plant, exactly where the active shooter is moving, and be able to have your system, your security system, tell you where they are, implement an evacuation protocol, make everyone real-time aware on their desktops, Windows desktops, or handheld devices, which way to move to get out of there, and then first responders know exactly where to go to deal with the person, and perhaps even be able to lock them into areas, lock them out of areas, give refuge areas for the employees to go to while they're dealing with the active shooter. So we know we've had some serious incidents going on, in a plant environment, if there's shots fired at a plant environment, well, where are the bullets going? And, how do you know? So that's real important. The trajectory we talked about a few minutes ago, that's important. But let's talk about something else here in a minute. Plant environments, airports, with the fence-based detection system we just showed you a few minutes ago. There's all kinds of them. Dave pointed out one the Israelis have. The Israelis got a whole ton of those, and I've used a bunch of Israeli systems. But in this case, we've got this system that'll tell you right where the incursion is. And again, you don't want nuisance false alarms, so the analytics are very important there. What infrastructure is at risk? I don't know. It's all at risk now. Used to be key targets. Used to worry about chemical. Now energy sites are getting to be a real big deal, especially electric power, but oil and gas is right there behind it. And depends on where you are in the world, right? So let's talk about a case study here. Most of you have probably heard of the Pacific Gas and Electric Metcalf Station attack that happened about 13 hours after the Boston bombing. During that time, you probably didn't hear about it, but it was essentially a special forces style attack on a site there. John Wellinghoff, the former head of FERC, Federal Energy Regulatory Commission, said this was probably the worst attack ever on American infrastructure, at least for electric power for sure. And the problem was we didn't have real-time situational awareness or anything like that, so it took an hour. The shooting went on for an hour. It took an hour for the police to get there. Actually, the adversaries cut the telephone lines, the internet capability and everything else. They cut all the fiber optics coming in and out of there. And then took about 2 hours once they figured out there was a problem, 2 hours for maintenance to arrive, and they really weren't aware of the extensive damage or what was going on there. They just knew the transformers all had shut down. So here's a chronology of the event. comes out of the Wall Street Journal. At 12:58 a.m., the attackers went into underground there, popped the lid on the manhole, cut the cable. AT&T put out $250,000 reward for the capture of these people. So far, that's not been paid yet. They don't know who it is. The attackers opened fire on the substation at 1:31 a.m. in this area, shooting in this area, and then this is not totally accurate. I'm going to show you something a little bit better in a second. First 911 call came from here, which is the plant across the street, and from the power plant operator at 1:45, the transformers all over the substation starts crashing. So, and then attack ends, gunmen leave at 1:50, 1:51. The police arrive 1 minute later, and then at 3:15 a.m., well, it's not as long as 2 hours, but it's a pretty good spread there. Utility folks arrive and say, oh, geez, we've really got something going on, so they launched a serious investigation here. It wasn't just vandalism. Here's, a freeze frame of the sparks. Sorry. Let's see if we can go back. Freeze frame of the sparks, the bullets hitting the fence. There were many, many, many frames of this video that went on and on for a very long time, as you can imagine, at that Metcalf station. So the problem is they actually did have these cameras and all this, but the sensor systems they had were passive and they were inadequate. So not only do you have to have sensors that know what, give you good situational awareness, but you also have to be able to act on that as fast as possible immediately, right? And that's been the real problem. So we have computer modeling that we do for Sandia National Labs, DOE, libraries, software libraries we used for performance of the adversary, performance of response forces, and performance of the equipment and things like that, and that all gets figured into the geography and the layout of the assets and resources that are being protected. What you have here is a timeline where an attack team moved through, and this is essentially the pattern that they followed in this attack. So we remodeled it, and this is, cumulative over time. And so this is where they shot into each of the transformers. Someone had been there before and laid out markers, like Special Forces pre-con markers, so they would know exactly where to stop, where to aim, and where to cause the exact damage they want. In this case, they didn't want to really kill the station. They just wanted to kind of bring it down, prove a point, we guess, by just hitting the oil reservoir tanks to cause the transformers then to start to heat up, and then for them to have time to shut down. There are a lot of other ways, of course, to attack it to make the transformers blow up. So what we did was we said, okay, here's what the likely passive security upgrades that happen with sensors. And Dave talked about the Israeli system that looked, using video analytics, looking down the fence. We use a lot of thermal. And that's also good for thermal on a pan tilt zoom head. You can look at your infrastructure and see where you have problems and things like that. We have leaks and things. And these are the gunshot detection sensors. This is the likely upgrade. This was not all in place during the attack. Some of it was, some of it wasn't. But the gunshot detection sensors we're talking about are, this is relatively the pattern that they would probably go. This is about 25 feet long, 750 feet wide. We've got U.S. Highway 101 out here like this. So we've got barriers here, sensor fence, that sort of thing. But the problem is one, what we saw was, I'm supposed to be going back. Let's see if we can go back there. Okay, so, but the problem is the adversary gets in. There's really nothing to stop the adversary. There's no on-site forces or anything like that. They have since put unarmed folks on there, and they made that public, so I'm only saying it because they made it public. Put unarmed forces on there. Unarmed force will not do anything against these kind of folks. So what the idea is to expand that sensor array, and gunshot detection is one of the great ways to do it. Gunshot detection does a lot of things. It's an acoustic sensor. Everybody talked about acoustic so far in the last, Tim and Dave both talked about acoustic. So that's one way of doing it. There's radars. There's all kinds of different things that are perfect for this. So we can tell way out and using analytics, all types of analytics, we can then determine, put the business rules in, and then only alert us when, if someone's moving in this direction, if they're shooting, that sort of thing, if they're just passing by, and maybe even hunting and shooting at an animal or something like that out here, the trajectory is not this way, then the business and the rules would say that's not a threat. Now, we may still want that to be sent to the control room and let them monitor the situation, but it doesn't come up real high as far as an immediate threat situation. So I just removed the gunshot detectors from here just to not make it too busy, but they would be present in the situation. So then what we do, and this is something I don't want you to try at home, but our patent pending approach here is the ability then, we've picked up the sound, we picked up the sensors have picked these guys up, they've seen them as a threat, and so what we're doing now is we're using non-lethal laser dazzlers, long-range acoustical devices, and perhaps even the millimeter heat wave that the military has, and Raytheon has actually civilianized version of that. That would be the last resort. But so we could interdict out to 2 miles away from the infrastructure using the sensors and then driving the actuators, and then a human in the loop says, am I going to engage these folks or not? That way, the system just doesn't zap them, okay? But this keeps us from having to shoot off-site, killing people driving by on the highway, keeps the adversary from being able to see well, hear, and be able to attack. In most cases, even a special forces group would be pushed back, would be repelled without anybody actually getting hurt. So that's the idea. So using sensors to drive actuators. And that's and this is just an example for security, but certainly you could use it for many things, right? So we ran a model on that, and everybody's got computer models. Remember, we just ran a computer model to show the attack. Well, this is remodeling it using the remote control active denial defense system that we're talking about. And you could certainly do this for any kind of a situation in a plant environment using that inductive reasoning I was asking you to use. And so what happened here is the blue is actually those actuators putting the beams and sight, sound, and touch on the adversary, and so what you now have is blue is good, so there's a few red lines here. As soon as this attack starts, it stops. So $15 million worth of damage, or perhaps even more. It could be a couple $100 million if the site goes down. But $15 million of damage did happen to Metcalf Station would be averted. So again, this is just a comparison between the two. That's the attack that was successful. They came and went. In this case, they would have started and it would have been all over. Situational awareness, going back to the control room, we actually poured it into the police cars, and that's what a Special Agent retired Farron gets to do. He gets to work with the police and gets to the control room and everything, and gets to bring the police in. And the police actually we can port this off to the police and let them control this so they can get tactical control of the environment as they move their own folks in. So intelligent integration, as Dave was talking about, as Tim was talking about, intelligent integration, that's the most important thing, right? We've got to be able to bring this stuff in. Of all the different systems you have there, something anomaly and problem in the process control, maybe on a pipeline or anything, can actually have a security implication for us when we start putting all the essential elements of friendly information together, right? And we create intelligence, and then we can have some situational awareness there. And maybe it's a pipeline, we send a drone on down to take a look. So, key components of intelligent coordination is the intelligent coordination. Automatic collection, distillation, and fusing of detection sensor information. First develops immediate situational awareness, right? We want to know what's going on. We want to be completely aware as best we can. And second, we want to orchestrate on-site countermeasures toward an attack or implement safety measures, for instance. So pattern recognition is very important, right? Now we're distilling this and fusing this information. We're out on the edge. That was mentioned by Dave too. Let's get that out on the edge. This gunshot detection technology is an example of an on the edge, very, very intelligent system that does a lot of different things. The acoustic capabilities are just basically endless. The idea of taking the fiber optic line and grabbing that and using that for multi-purposes, including picking up signatures, sensor signatures of patterns of sound is a way to go. You can tell on a train line or a pipeline 30, 40, 50 kilometers away that you have people walking around, or digging, or a vehicle, or a backhoe digging down into your oil pipeline, that sort of thing. Not only shots fired activity, you want your system to be trainable. You want it to be able to ignore things that you don't want to know about, right? You got all this white noise, and all you want to hear is voices or hammering or whatever it is. Context-dependent recognition. So it's trained the system. These systems are trainable. And again, pick out speech from white noise, for instance. False positive minimization. The more analytics you got going on, the smarter the system is able to do it. You can cut down on that. Speed, accuracy, and then using common industry standards so that you're compatible, right? Make life better. So examples, again, fence line breaches, ground and air breaches. Air breaches. What were we talking about air breaches? I just saw something on TV yesterday. It was all about all these drones that everybody's flying around airports now. Pilots are reporting they're seeing drones. So drones around your plant, drones around your airfield, drones, you know. So we can detect the drones. We can determine where the drones are with this kind of technology. And then we can drive a sensor actuator, and maybe we hit it with a foam gun. I mean, I'm just using inductive reasoning here. What could we, do to keep them out, right? Launch a counter drone, right? That's all possible. I can tell the people in this room, or your heads are whirling on this stuff. Okay, so anomaly events is really what we're looking at. Leak detection, mechanical malfunctions, all can be picked up with this multi-purpose sensor system. So, it's all about getting that value, right? So this is what we don't want to happen. This could be an accident, or this could actually have been an attack. This is a combustion turbine, I think it's a combined cycle plant down in Texas a few years ago that had and it's a natural gas fed plant. That's the fuel type. And so that was one of the results, and that was the cooling towers obviously had their job was a little too big. So again, let's get ready to use inductive reasoning and ask some questions. And I thank you very much for your time and attention.